Thank you.
Thank you. So I'll just start my timer. Good afternoon, ladies and gentlemen. I hope you had a nice lunch and that you're all ready for the next talk. Yeah? Nodding is allowed, yes. My name is Juna Henriksen. I am from Norway, and I work for a company called Red Pill Impro. And despite the logo containing a pill, we're not a pharmaceutical. We are a consultancy company. We work with open source software for the most part. We do a lot of sysadmin, hosting, development, courses, that sort of thing, the whole jazz. I am here today because I would like to talk to you about something called creative coding. When I say creative coding, I don't mean end products. I will be talking about how the brain works when you are programming, because I think it's very interesting, and also that it is really important because it is your most important tool. It is not Emacs, it is not Y, it is not whatever it is you prefer to use. It is your head. And I like to know how things work. And I guess you do too, right? Nodding? Oh, excellent. Okay. So you can all hear me just fine, right? Yeah? Okay. So this is a quote I like, which is from the Mythical Man Month, which you probably have heard of. I would just like to say a little bit about why I got interested in the subject, because I have, I like talking about or talking with people who are getting into the profession, trying to get people to work with programming as well. And I was reading an article about a woman who was being asked about her career choices. And upon asked whether or not she would become a programmer, she said, "It sounds like it could be fun, but I'd prefer to do something that has to do with people or something that is creative." And to that, my response is, okay, people, great, I get that. We do not work that much with people, at least not as much as a teacher would or a nurse. But that is not creative. That's just wrong. It's not true. I mean, how can it be? We are creating something out of nothing, right? Yeah. Okay, so this is what I'll be talking about. First, we're going to go through, we're going to have a bit of basic information, a little bit of background. Then I'm going to talk about how the brain works. Yeah, left side, right side, the process that you have in your head, cognitive skills, that sort of thing. And then we're going to get into why should you care? Is there something in programming that is doing this already? And then I'll just do a bit of summary. Yeah? Excellent. Okay, so what is creativity? The definition as we understand it today is that it's something new that has value, where new varies, and so does value. It could be quite confusing, but if you didn't think it, you probably wouldn't say that you are creative, right? But you actually are, at least from this definition, because creativity is kind of a problem solving, really. It's a way of solving a problem. So this example here is one domain. This is you. Whenever you have a problem and you're trying to solve it, and you can't find the solution by Googling it, then you have to think about it. That's a creative process. If you find an answer when Googling it or asking a friend, this is application. That is not creativity. So when you are programming and coming up with something new that is of value to you, then you are being creative. And this, we can agree, is a kind of problem solving, right? That is Mark Zuckerberg. He invented Facebook. That was creative. It was something new in that domain. I mean, we've had that kind of service before. We have. But it was new in that domain, how it worked. So that was being creative. This is probably the more traditional sense that we're used to thinking about when we are talking about creativity. This is Thomas Edison. Right? So when he invented the light bulb, that was something new that was of huge value to the entire world. Everyone with me so far? Excellent. So, I mentioned this is the way creativity is understood today. It wasn't always like this. During the Renaissance, it changed, and in the Enlightenment, that's how we finally understood how it works. But before that, it was actually thought that we couldn't come up with something new. If we did, it was an act of God. It's a divine being that was sort of acting through you and creating something new. Because we as people couldn't do it. It just didn't work that way. It was God that did it. And it was believed that we didn't have an imagination. That was something that came about during the Enlightenment, which is really interesting. At least I think so. When we were trying to understand how something works, I like to think about what kind of research is there. And here we have a couple of them. Creativity is something that is interesting for several types of fields, everything from psychology and neuropsychology to education, and also economy, creative economy. Imagine that. And this is one of the fields that I think is quite interesting, is creativity and intelligence. Is this related somehow? We don't really know, because studying the brain is, sorry, is really hard. And because it's hard, there are several camps, right? And one of those camps believe that it is something that is different. Some people believe that the processes that go on in your head are completely different. The process that you have in your head when you're doing something, when you're solving a problem, is just one part of your brain, and you're using different processes in your head when you're being creative. Other people feel that they are the same. And a third camp thinks there is a sort of threshold. That means creativity and intelligence is linked. If you are creative, you are also intelligent. And this goes up to a certain level, up to about an IQ of 120. And I personally believe that's to be true because they have a lot of tests on it. They've had tests on a lot of students, and it seems like above 120 in IQ, and you choose. You either get more creative or you get more intelligent. So another field of study is lateralization, meaning where in the brain is stuff going on when you are thinking about things. So when you are creative, where in the brain does that happen? Is it lateralized? Does it happen in one side of the brain or the other, or both? Right. Also, you can become more creative. It's not like you start at one level and then this is something you're born with. You can actually work on it and become more creative. Also, they are studying on how you can use creativity to make people learn better, use techniques, creative techniques, to become, to learn. Yes. All right. So that was the basics. All right, now we have one more. The creative process, as I mentioned, it is a way of solving problems, right? These are the different stages that you go through when you are being creative. Say you have a problem, you're sitting at your desk, you're solving a bug, and you can't really figure out what it is. You've tried Google, you've tried everything, you don't know what it is, you just have to go out and do something else. Being creative is an asynchronous process. So you have to do something else to find out, to let your brain work on it, to find a solution. This stage is called incubation. That means when you're doing something else, your brain isn't not thinking about it. It is, but you're not conscious of it. When it has worked through all of your memories, which we believe it does, it will try to tell the part of you that you're sort of aware of, that, okay, I think I have the solution. And this insight that you're going to get, that could be somewhere completely random, or something that it feels like it's not related. Like Einstein, he came up with the relativity theory in a dream. The guy who invented the sewing machine, he had a problem with the head of the needle. He didn't know how to work it. And he saw a snail. And he was like, all right, that's how I'm supposed to solve it. Because the shape of it gave him an idea of how he was supposed to solve that problem. Once you get that insight, you need to do some verification to check that it actually works. This is just one model of how we think it works. There are others as well. They usually have one extra step, but these are the basic ones. Yes. So that was the fundamental part. Kind of a long introduction, but I hope you are still with me. This is how the brain works. You're probably aware that your right hemisphere controls the left part of your brain, the left part of your body, and the left hemisphere controls the right part of your body. During the 60s and the 70s, there was a lot of, we started doing split brain surgery, and this is why we know that works. And also, if someone has a stroke in the right hemisphere, you'll see that the left part of the body can have some paralyzation. So this we know is true. Also, because of this, there was a lot of sort of a guessing game going on. So people thought that because they had a stroke, they would see what was missing, right? So they would think that because they had a stroke in the left hemisphere and then they couldn't speak, that means the left hemisphere is controlling all of speech. This is language. But we now know that's not true. It's a misnomer. It's not true that the right hemisphere controls images. It's not true that the left hemisphere controls speech. It's not. It's the dance of neurons sort of that goes on both sides. And if you have a stroke, you can, the parts around the brain that could learn those functions, or the parts in the other hemisphere, which is similar, can also can learn those functions. You can learn to talk again. Right. However, there are some structures, or some controls, some processes in the brain that are lateralized, that are on the right hemisphere and that are on the left hemisphere. And that is attention. This is just a way of describing how that works. When you are trying to understand something, you take in everything at once. You don't look at the little pieces and try to put that together to understand it. You take it all in at once. You've probably seen on Facebook, you get one of those. Can you see what this is? And you look at an image, and it's just nature. But if you look at it closely, suddenly it appears, all right, it's a baby in a crook, or, yeah. That's the right hemisphere that sort of gets it everything at once. Mm-hmm. And once it does that, it will pass that information through the connection it has in the back of the brain to the left hemisphere, and it will choose which part it's supposed to study. And when it does that, it goes back and get a bigger picture. So it's a sort of pattern going on. Big picture first, then you look at the little ones, and you go back to the big picture again. So it's the attention, and those are lateralized. Patients that have had strokes in the right hemisphere will lose the big attention span. And because the left part of your brain controls the right part, they can be walking out through a door and focusing on things often on the right. And they can't get away from it. They just start studying it. They can't stop studying it. And someone has to sort of kick them or get them out of that before they can start moving on, right? I'd love to have one of those people and just look at what they do, just to see how it works. Okay. This is one model. This is closer to the truth. what we are going to do is use the dual CPU brain. This is another model. And it's a metaphor, meaning it's not the truth, but it works better to understand how the brain works and for our purposes. So your dual CPU brain, instead of talking about left side and right side, we're talking about modes. The linear mode and the rich mode, or CPU 1 and CPU 2. And they have a common bus up to a memory bank. And now I'm going to describe a little bit how they work. So CPU 1 is like a linear von Neumann, that's how you say it, process, meaning it takes things step by step. It's logical, it's synchronous, it does algebra, language, things that we're all very aware of, right? This is what you get tested at in school. It's common stuff. This has got a lot to do with programming and how we understand it today. Well, how we commonly understand how it works. Whereas CPU 2 is asynchronous, and you can think of it like a Google engine. It will go through all of your memories with the regex pattern and come back with the result. See the linking to the creative process? Yes? They share a bus, and this is important. It means that when CPU 1 is accessing the memory bank, CPU 2 can't. If you are looking at a problem and trying to solve it by going through it step by step, you can't use CPU 2 to solve the problem. You need to go and do something else. You have to give CPU 1 a break. You have to give it something else to do, something that's boring, which it doesn't need the memory bank for. It doesn't have to be boring. It can be just, it can't use the memory bank. Because CPU 1 also has an idle mode. It just keeps on chattering. So if you're not giving it something to do, it will just keep on. It's the voice inside your head. So it's quite common to think that this is you. But when a thought comes to CPU 1, it's actually quite old. It's been in your head for several milliseconds. Right. So this is a little bit more about the linear mode. These are the different cognitive skills or processes that we have in our head. So we can group the different things. As I said, language is here. CPU 2 or rich mode, it doesn't understand language. It can retrieve language, but it can't understand it. Linear mode does. It's verbal. It's also digital. It can count. It's temporal. It cares about which order things are in. This thing happens first, then this. It's rational, meaning it can come to conclusion based on reason, based on facts, whereas logical is based on reason and theorems. Linear is linked ideas. I need to go to the shop to buy something because I'm hungry, so one thing leads to the next. Sort of similar to the voice in your head kind of thing. Analytical. This is also something we use every day when we are programming. You have a problem, you have a bug, you want to figure out how it works. You take things apart. Okay, read through the code. How does this work? That's the analytical bit of you. And abstract, you take a piece of something, and that represents the whole. Also familiar stuff. We even have a construct in PHP which is called abstract. Right? It means the same. Symbolic, also something that we use every day. I mean, we have variables. Right. It should be relatively familiar stuff. This is what you get tested at in school. It's easy to test. So now on to rich mode. This is the one. This is the side I'd like us to focus on. We're not doing enough of it. left mode is actually, especially in the Western world, linear mode has taken over, which is a bit sad. We've forgotten about it. I think it is a bit better in the Eastern world, but language, for instance, is very, very important in the Western world. And intuition, that kind of thing, is sort of frowned upon. You're not supposed to do that. You're supposed to logically come to a conclusion. The leap of faith thing, so it can easily be disproved, right? But it's actually very important to get to an expert level. So rich mode is non-temporal. It doesn't care about time. It's holistic. It looks at a problem from all angles at once. It looks at the whole picture. Not just the little pieces, and comes to a conclusion on that. It's non-verbal. As I said, it can retrieve language, but it doesn't. It cannot create it. If you've ever had a dream, and you wake up, it's really vivid, and you try to explain it, it sort of evades. It goes away, and that is because you're trying to describe it in words. And rich mode is in pictures. Rich mode does pictures. It doesn't do words, which is why you can't explain it. It's the same thing happens if you're trying to describe a close friend or a family member. You can recognize all of your family members, even if they grew, they got really fat, or if they got really old, or if they changed their hair color. You still recognize them, because rich mode has exceptional perceptual power. Something we can use when we're programming, and I'll get to that. Right, moving on to the other ones. Analogical, also very important when we're programming. It means, it has to do with metaphors, but in this example, it means the heart, it's a pump, right? So heart, it's supposed to be a pump. I'm not a very good drawer, but it has to do with metaphors. You take meaning and of one object and you transfer it over to another object. I'm really excited about analogical, and we'll get to that later. Intuitive as well. This is an expert trait. Really important. This one usually is 1 + 1. Doesn't have to be, I think. Yes, it has to be. But it's intuitive. We can't really see it, but it will be. Synthetic. As opposed to analogical, where you pick things apart to understand it, you build it. They have done studies on this. For instance, instead of dissecting a frog to understand how it works, some schools in the United States try to make them build a frog instead. And that has a much better effect. For example, using Lego bricks or what are they called? Well, those mechanical Lego things. Mechanic, is that what they're called? Meccano, right. It's also concrete, rich mode, meaning it cares about where things are in relation to each other. Spatial regex thing, that's the facial recognition bit I mentioned earlier. And non-rational, which is kind of insulting. Why would we want to be non-rational? Doesn't make sense, but you do make a lot of non-rational decisions in life. For instance, if you're married or have a girlfriend, you didn't make a pro or con list to decide whether or not you wanted to be with this person, hopefully. Yeah, it's a leap of faith kind of thing. It's a non-rational decision, which does make sense in some cases. Have I gone through all of them? Yeah. Right. So, how can you use this? On your way to becoming knowledgeable about whatever you like, it doesn't have to be PHP or programming, it could be whatever you like. You go through different steps. There's something called the Dreyfus model, but there are other models as well. The Dreyfus model has 5 different stages. You start with the bottom level, the beginner's level, where you don't really know anything about what you're trying to learn. You're really impatient at this level. When you have a problem, you just want to solve it. The good thing about this is you can put these people to work. This is why call centers work. You give them a list of things to do. If this goes wrong, then you do this. If this goes wrong, then you do this, and you sort of move down a set of instructions. Coding standards is a way of making beginners useful. It's an easy thing to follow. It's a set of rules. Then you have a bit above that, 5 stages, and in the end, you will come to the expert level. This is where we want to be. They are intuitive. They don't really know how they've solved a problem often. They can't explain it, which is why you shouldn't have an expert teaching a beginner, because they don't really, they just know. They just looked at the problem. It felt like that was the solution. Experts are, there's not a lot of them. Maybe 2% in the world are experts. These are the source of information in that subject. I think there are a couple of experts in this room, actually, in PHP, who are sources of knowledge. But everyone can get there. It takes hard work. Yes. Pattern matching. That has to do with coding standards as well. We, as I said, for beginners, this is easy to do. For experts, this is something they need to recognize where they are. People in the middle, they don't really care about this because they don't see the use of it. Why should I document the code? I mean, you could just read the code. But when you see a structure of code, a function with the doc block on top, you easily recognize where you are, which makes it better. It makes you more efficient. It sort of triggers the intuition a bit. Mm-hmm. Right. Holistic and analogical. This is useful when designing. Good design is actually very important because when something is pretty, when it is beautifully designed, people understand it better. It just works better. They've been doing tests on this. We don't know why. It's just the way it is. They even thought it was like a cultural thing, but they've tried it in the Western world, in the Eastern world, and it's weird that it is like this. But if people, even if they're just primed with the Apple logo, they get more creative. It's just a bit weird, but that's how it works. As I said, learn by synthesis. Already gone through that. Analogy and metaphors. We use a lot of metaphors in programming. We don't have daemons in our computers. We don't have threads. We're not sewing when we're dealing with threads. But we still call them that. One of the examples I think is funny with PHP is exceptions. When you're throwing and catching an exception, that's the metaphor. You're not throwing anything or catching anything, but we call it that, and it says something about how it works. It says a lot about exceptions and how it works. So that's brilliant use of metaphors, in my opinion. Also, metaphors are better if they are funny. So this is a good reason to be funny when you're coding. Try not to use obscure TV shows, for instance, when you're being funny, because in 5 years, Big Bang Theory might not be as popular anymore, and no one knows what bazinga means. But it is true. Another example of I think is funny in PHP is when you're cloning an object, you're referencing the object you are cloning as this, and the one that you are cloning, the one becoming the object you're cloning as that. So you have this and that, which is a bit funny, right? At least I think it is. Also, metaphors. Pair programming, that is where left and right mode meets. Some people believe you can pair program your way out of any problem, but the way I like to think of it, one of the more useful uses of pair programming is you have one person sitting at the computer doing the coding. This is the person who's sitting in the narrow attention span, because the other person is sitting, he's not at the laptop, he's standing right and thinking in bigger pictures. That way, you can be in both the left mode and the right mode at the same time, which is very useful. And I hope that you probably discover this when you have been pair programming, that you can sort of get, you can view the sides of the problems from different angles at the same time, and you get to a solution faster. You still with me? Yes? Excellent. Right, so here's an example. The code itself isn't as important. What is important is the way it looks. It's, you see the color coding? If you've ever tried to look at code without any color at all, it's so much harder to read. So for an expert to have things the way he is used to, it's really, really important. You see the color, the dot block up there, and everything is indented. So this is the spatial cognitive skill from rich mode in action. Right. Synthetic. We are actually using the synthetic skill already when we are prototyping, and also PHP when we are unit testing. When you are prototyping, that means you're trying to figure out how to solve your problem by building it. Yes, I do this, and I'm pretty sure a lot of you do. When you have a problem, you want to try to figure out how it works. You try to build it. You just try to sit down and you start coding it. This is being creative. This is good. This is a tool you have for using the right side of your brain. So it's not all bad. We are doing good things as well. And the same thing is true for unit testing. You are building something to check if your original solution works, or the one you are going to build. This is why it works. Do you understand that this is true? This is sort of give you a, yeah? Okay. Right. Another example of analogical or metaphors. This is one of my favorite examples. The scream setting. I don't know a lot about how XDBot works, but this setting is brilliant. What it does, it disables the shut up one, so you get all of the error messages. You know you will get them. So instead of having a setting which was called disable at, for which order was it, I don't really remember, you have scream. It says exactly what it does. It's funny, and it's a metaphor. This is how it's supposed to work. Do you agree that this is a cool thing to do? Again, with the Bazingers and Big Bang Theory, don't get overexcited and try to do things too much, but getting a good understanding, using words that everyone knows what is what I'm getting at. That's what you should use as metaphors. Right. I already mentioned this. This is a nice picture wanted to include it. Okay, something you shouldn't be creative with is test data. You never know how it's going to get out in the open, and it most likely will. I've heard stories about people adding, especially with profanity, if you are trying to be funny, adding sort of profanity to reminders, for instance, and you forget to take it out before it goes into production, and you're sort of spamming your users with profanity every 2 weeks until someone noticed. This is not good. Another example I read about was a Bill Gates-shaped personal massager was left in the web shop that they had for every user to buy. It cost like £1 million kroners, so £1 million. So no one wanted to buy it, but you don't want that to come out to your customers. And it doesn't have to be something you actually put in production. It could be a salesman who comes up and wants to do some screenshots to present to the customer. You have no control of this. So I mean, there's nothing wrong with test data, but just be careful. This is not where you should be at your most creative level. Use it better, use it as something else. Easter eggs, also a nice way to be creative, in my opinion. We have, this is Google Moon. It's not effective anymore, sadly, but if you, at least in, I think it was 2005, if you zoomed enough in on the moon, you would see it was made of cheese. This is a cool Easter egg. They don't have pictures of the moon that close, so why not? So if you do it today, you'll just get like no stock image. So you should put that back in. It's funny. PHP also has some Easter eggs, at least PHP.net. It has the, if you put they have different codes, and if you put that at the end of some URLs, you will see that they're using PHP. You'll get different images. There are different codes. You can look it up. The other one is the Konami code. It's that sequence, up, up, down, down, left, right, and you'll get, they'll change the logo on PHP.net. A lot of websites actually has the Konami code. It's from a game, I think. I don't know which one. I don't think I played that game when I was little, but Facebook had that Konami code as well. You would get bubbles that would sort of fly around on the web page. Yes, and the bottom one is from a varnish. If you're trying to do something you're not supposed to do, they will give you the 418, I'm a teapot, which is from, I think it's leftovers from a April 1st joke. They made a standard. It was called 4108, I'm a teapot. And someone decided they wanted to implement it. It was just a standard, but it's a lot of people actually will return something if you get 418. Right, so this is the summary. Metaphors. I like metaphors. You should too. It's funny and yes. Another one is you're learning by synthesis. It's good. We've covered that in length. And have fun. It's important. It will engage the right side of your mode, and that your right side of you, and you will be more creative. Oh, exactly 40 minutes. Yes.
So we have about 4 minutes for questions. Does anybody have a question? Right.
It's more of an observation. It seems to me that metaphors, using metaphors, is really important in making stuff intuitive for other people. Like Scream is very intuitive because it's a metaphor. So they kind of play into each other.
Yeah.
So that was all.
It's an observation. Thank you. I agree. Anyone? Oh, we have one in the back.
I'm just wondering if you have any advice for the workplace, things we can do to get a bit of creativity flowing, ideas moving around a bit more.
Yes? Really, I think management is important in this, actually, because they have to realize that even if you're not working, it doesn't mean, if you're not doing anything, it doesn't mean you're not working. It's the fact that you're not doing something. And this is important. So allowing people to do something else and sitting in front of the laptop is actually important. Outside some hospitals, I don't know if you've seen it, hospitals and universities, they usually put out labyrinths. There's a difference between labyrinths and mazes. Do you know the difference? No? Labyrinths means that you can just walk and walk. It's like you're going for a walk. Mazes means you have different paths and you have to find your way out of it. It's more like a puzzle. Labyrinths are meant to sort of just go for a walk in confined spaces. This is the way to become more creative, because the left side of you will sort of disconnect and allow the right mode to take control. So getting back to nature is actually a good thing. And having a labyrinth outside the hospitals and universities have a good effect, I would think. But also allowing people to not sit in front of the laptop is actually good. So if you have a problem, just step back, do something else, and you'll be surprised at what results you'll get.
So I think, was there one more question this side, or? No? Okay. In that case, I think we probably better wrap up there, because there's a very small time space
like
to get to the next talk.
Thank you.